All right, today we're going to dive into something super cool, and honestly, a bit of a secret weapon built right into PostgreSQL, the notify and listen commands. If you're building any kind of real-time application or a distributed system, this is a design concept you absolutely need to know.
Yeah, you heard that right. A lot of the systems we build every day have this hidden vulnerability, this little crack in the foundation that can cause critical data to just get lost in limbo forever. So let's figure out what that is, and more importantly, how we can fix it.
To get our heads around this, let's use a super relatable scenario, placing an order on an e-commerce site. It seems so simple, right? You click buy and the magic just happens. But behind the curtain, it's this complex journey with a ton of steps and some pretty surprising places where it can all go wrong.
Okay, so the standard flow is pretty simple. You, the user, hit that buy button. Your server grabs the request, it shoves a new row into the orders table in the database, and then it shoots back a success message to you. Easy peasy.
But is that really enough? Spoiler alert, no way. In the real world, just getting that order into the database is barely step one. You've got to notify the warehouse, kick off the delivery pipeline, update your inventory count. That one single database write needs to set off a whole chain reaction of other tasks.
So how do we usually solve this? Well, we build event-driven systems. The typical playbook is first, you write the order to the database. If that works, you then fire off an order-placed event to some external message queue, like AWS SNS or Redis. From there, other worker services can pick it up and do their thing. Sounds pretty solid on paper, right? But this is where things can get a little messy.
Let's zoom in a bit, because this standard setup actually has two major and surprisingly common points of failure.
So what's so telling about this slide is how it just lays it all out. On the happy path, life is good, everything works. But check out the failure path. What happens if your database write succeeds? Great, but then your external message broker is down for just a few seconds? The message to process the order never gets sent. The result? That order is now a ghost in your system. It's sitting in the database, but it's never going to be fulfilled.
And then there's the second problem, and this one is way more sneaky. What if a developer or a support agent needs to manually insert an order directly into the database? Well, because they went straight to the source, they completely bypassed your application. And that means your event broker has no idea this new order even exists. Your system is now officially out of sync.
And this is where PostgreSQL comes in to save the day. It has this incredible built-in pub subsystem that solves both of these problems by moving the notification logic inside the database itself.
So what is this thing? Well, you can think of notify and listen as a tiny built-in messenger right inside Postgres. It basically lets you tell the database, hey, whenever data changes in this specific way, I want you to send out a little message on this specific channel. It's that simple.
And here is the absolute game changer. The event notification is now part of the database transaction itself. This means the data change and the notification are a package deal. They happen together or not at all. It doesn't matter how the data got there, your app, a different microservice, a manual query. If the row gets inserted, the notification gets sent. Guaranteed. The database is now the single source of truth for your data and your events.
All right, so how do we actually put all this together? Let's walk through it conceptually. No super deep code, I promise, just the big ideas you need to get started.
So first, on the database side of things, it's pretty much a three-part recipe. You write a little function that takes the data from a new row and wraps it up nicely in a JSON payload. Inside that function, you use the pg notify command to broadcast that payload onto a channel you name, something like new order channel. And finally, you create a trigger that basically tells Postgres, hey, after any new row gets inserted into the orders table, run that function for me.
Okay, now for the fun part, the backend. And believe it or not, this part is even easier. Your service connects to the database like it always does, but then it runs one special command, listen new order channel. That's it. It's like tuning into a radio station. From that moment on, your application is listening for any messages on that channel, and you just attach a simple callback function to decide what to do when a message comes in.
And boom, this is what your listener gets. The second a new order is inserted into the database, let's say an order that was rejected for some reason, your backend immediately receives this JSON payload. It's literally the data for the new row, sent in real time, ready for you to process it safely.
Okay, so this isn't just some neat party trick, right? Let's talk about why this is such a big deal in a real-world system design.
I mean, the possibilities here are huge. You can power real-time analytics dashboards that update instantly. A fantastic use case is asynchronous billing. Imagine a user does something that costs them credits. Instead of making them wait while your server does a bunch of queries to update their balance, you just log the action, send a fast response back to the user, and let a background listener handle the credit deduction after it gets a notify. This is amazing for improving your API response times.
And really, here's the bottom line. You get way more reliability and perfect data consistency, all without adding complicated external moving parts to your architecture. And by pushing work into the background, you can make your main user-facing application significantly faster.
So there you have it, PostgreSQL's notify/listen. A really simple idea with some seriously profound power for building better, more robust, real-time systems. So I'll leave you with this question. In the systems you're building, where could a talking database make things a whole lot more reliable? Thanks for watching.